Okay, so, we're gonna do cosecant. The reason we're gonna do cosecant is because it is the reciprocal of sine. And so really what I want is for you to see that relationship, okay? I lost my pink pen. I think the pink pen shows up easier. Okay, so you should have your little, you know what I'm talking about? This one, you should have this handy, okay? Now, I didn't fill my whole thing out, I just filled out the last part because that's all I'm using. I couldn't find my key on there, but I didn't do it, so whatever. All right, so I'm gonna start down here. Now, the cosecant of 0 is undefined. So I'm gonna pretend like I'm y'all and that I have no earthly idea what that means and how do you graph undefined. So I'm gonna skip it, okay? Because y'all listen to me. If you skip things that you don't know how to do, then you may see something that may help you figure it out, okay? So I'm gonna scoot on down, I'm gonna do pi over 6. The cosecant of pi over 6 is 2. Now look, really, what am I doing to these numbers right here? I'm flipping them. That's all I'm doing, okay? I'm just flipping them. So the reciprocal of 1/2 is 2. The cosecant of pi over 6 is 2. So here at pi over 6, I'm going up to 2. Putting a big dot. Everybody with me? Okay, so then I'm moving across. The next thing I have is pi over 4 on my x-axis. So I go to pi over 4, and I go down here, and I have the square root of 2. So I look over here where I found all my values, okay? Remember we did them all? And I said the square root of 2, 1.41. So at pi over 4, it's 1.2.4, so just above the 1.4. All right, the next thing is pi over 3. So I look at pi over 3, and I look down here at cosecant, and I have 2 over the square root of 3. I look over here, and 2 over the square root of 3 is 1.15. So almost 1.2. Here's 1, and here's 1.2, so almost 1.2. Does everybody know what I'm doing? Speak now. Okay, so now I'm going to pi over 2, all right? So at pi over 2, I'm down here and I'm at 1. The reciprocal of 1 is 1. Pi over 2, here's my 1. All right, now I'm going across to 2 pi over 3. So my chart, that's my next thing, 2 pi over 3. He is 2 over the square root of 3. So I look over here, 2 over the square root of 3 is 1.15. So that's almost 1.2. Oh, you starting to see something?
Mm-hmm.
Okay, do we think we know what's fixing to happen?
Yes.
Yes, you know, it's all about patterns, okay? So 3 pi over 4, here's 3 pi over 4. He's the square root of 2, and the square root of 2 is 1.41. So just above 1.4. The next one's 5 pi over 6. He goes all the way up to 2. Goes all the way up to 2. Pi is another undefined. It's the reciprocal of 0, okay? So, so I'm gonna skip it again, all right? Now, 7 pi over 6, I'm right here, okay? I'm just reading what's written down here. So 7 pi over 6, negative 2. So 7 pi over 6 is negative 2, all right? 5 pi over 4. 5 pi over 4 is negative square root of 2, so that's negative 1.41. So negative 2, 4, 6, 8, 1.2.4. Did I do that right?
Mm-hmm.
That's not right.
Oh,
Is that right?
Your
Something's wrong.
The pi
pi is not on.
No, it's not, it's good, it's right, sorry. Sorry. All right, so 4 pi over 3, 4 pi over 3, negative 2 over the square root of 3, so that's negative 1.15, almost negative 1.2. So 2, 4, 6, 8, 1.2, so he's right here. 3 pi over 2, are we starting to see a pattern?
Yes.
Okay, so 3 pi over 2, 3 pi over 2 is negative 1. Now, what's fixing to happen over here, guys?
It's gonna translate.
What do you think it's fixing to do?
Mirror itself.
Fixing to go where? No, yeah, he's fixing to reflect this right here. Yes, he's gonna go down. Okay? So, 5 pi over 3, 5 pi over 3 is negative 2 over the square root of 3, negative 1.15. So that's almost negative 1.2. 7 pi over 4, 7 pi over 4 is negative square root of 2, so that's negative 1.41. Eleven pi over 6 is negative 2. And then I have an undefined. Okay? So let's just look at this for a second. What do these look like?
Parabolas?
Yeah, if I connected them, don't you agree that they look like parabolas?
Yes.
Okay, so, I know that they're gonna do, I know that they're gonna do this. Okay, and I know that he's gonna do this. So, what is happening here and here and here? Because all of those, 0, pi, and 2 pi, all of those are undefined. What does it mean when something's undefined? Do you have an answer for it?
No.
Is it going to be on this graph?
No.
No, y'all, there's not an answer for it. It's undefined. It can't be that. What do you think my graph is going to do right here to this y-axis?
Flip what it did.
If it can't be it, will it ever cross it?
No.
Do you agree that? So what's he gonna do? Keep getting closer and closer and closer to it, but never get there? What is that, people?
Asymptote.
An asymptote, okay? So all of these undefined are asymptotes, okay? I'm gonna use my PreCal instead. Let me say that.
Do we have to get that address?
You have to draw the asymptote. Is the asymptote important?
Yes.
The asymptote is telling someone, is this really a parabola?
No.
It's not a parabola, okay? It looks like one, but it's really not. He has a boundary. A parabola doesn't have a boundary, okay? All right, and then there's one over here at 2 pi. Okay, now remember what I just told you about patterns and stuff. Y'all, if there is one at 0, pi, and 2 pi, where's the next one to the right? 3 pi, where's the next one? 4 pi. Where's the one to the left?
Negative 1 pi.
Negative 1 pi. Don't forget to draw the left part of your graph, you'll lose some points. Okay, now, where do you think that parabola is gonna be in this section right here?
Below.
At the top or down at the bottom?
Below.
Down at the bottom. We don't have those values, but I know they're the exact same values as this one. Do you agree?
Sure.
Okay, so at 3 pi over 2, it's negative 1. So at negative pi, it must be negative 1 also. Okay? And then, this is the way I cheat, sorry. I go to the left 2 and down 1. To the right 2 and down 1. So to the right 2 and down, I'm really at that one that's almost 0.2, but it's not quite. And to the left. And then the next one is that negative 0.41. So he's going from that point right there, he's going right 1 and down a little more than 1. So he was just right above that or below that point because I'm going backwards. going down instead of up. Okay, now I gotta get from this point to this point. Can you do that? From this point to this point. You're obviously gonna go down how many? 3, and then over 1. So down 1, 2, 3, and over 1. Down 1, 2, 3, and over 1. And here is my cosecant curve. Okay? Now, watch this. I want you to watch this. This is so stinking cool. You're fixing to learn a whole bunch of stuff. All right? So this is the reciprocal of the sine curve. Do you agree with me?
Mhm.
All right? Is sine and cosecant, are they even or odd?
Even.
Who is the only even one I told you you needed to know?
Sine. Cosine.
Cosine. Cosine is the only even one. I said you have to know cosine's even, and that makes who else even? Secant, and everybody else is odd. Okay? Everybody else is odd. All right, so odd functions, what you're gonna see this, watch. This is the sine curve. He starts right here, and he goes up to 1, goes back to 0, to -1, and back to 0. It goes like this and like this. Do you see it? You see it? Do you see how the zeros are my asymptotes? Because what's the reciprocal of 0? Undefined. Okay? And then we just take that curve and it just flips it. Took this one and he flipped it down. Took this one and he flipped it down. The next one's going to be up here. The next one will be down at the bottom. The next one will be at the top. And it keeps going back and forth. Okay? Pretty cool, isn't it? So is there a relationship between a curve and his reciprocal function?
Yes.
Yes, there is. And you should see a relationship. All right. So let me show you something else that's really cool. Okay? Let me show you something else. I'm going back to the sine curve because you're more familiar with the sine curve than you are the cosecant or the sine value. All right? So look at this. Look at the x-axis. Okay? This is 0. This is pi over 2. What quadrant is between 0 and pi over 2?
Quadrant 1.
Quadrant 1. So you can. So this is quadrant 1. What are the sign values in quadrant 1? Positive or negative?
Positive.
Everybody's positive in quadrant 1. Oh, everybody's positive in quadrant 1. Everybody will be above the x-axis. Okay? What's quadrant 2 go from and to?
Negative x, positive y.
What does quadrant 2 go from and to? My radian angles.
Pi and,
Okay, look, people.
oh crap.
This is 1, this
It's
is
1/2
2,
pi.
and this is 3, and this is 4. Here's 2. Oh, sorry. Here's 2. It goes from what?
1/2 pi.
Pi over 2 to
Pi.
pi.
Oh.
Okay? So pi over 2 to pi. This is quadrant 2. Who's positive in quadrant 2? Sine and his reciprocal, right? Cosecant. Okay? Remember, a cosecant's doing this. He's going up like this. Okay? Quadrant 3 goes from pi to 3 pi over 2. This is quadrant 3. Okay? This is quadrant 3. Who's positive in quadrant 3?
Tangent.
Tangent. Is sine positive?
Yeah.
Look at him. No, he's not. He's down here below the x-axis. His values are negative values. Okay? His values are negative values. So, and then obviously from 3 pi over 2 to 2 pi, that is quadrant 4.
Which is cosecant.
Okay?
Or not cosecant. Cosine.
And he's also negative. Cosine is positive and everything else is negative except for his reciprocal. Okay, so here's where you kind of see this, all right? if I go backwards, these are my negative values. If you go backwards this way, what quadrant are you in?
4.
The fourth quadrant. This is the fourth quadrant, guys. Okay? This is the fourth quadrant. Oops, I missed it. So, this is quadrant 4. Alright? Obviously, this would be quadrant, what?
3.
3. In quadrant 3 and 4, sign values are negative. Tangent's positive in 3, and cosines positive in 4. Alright? That's pretty cool. Isn't that cool? That's just another way to look at it. Now, here's what I'm gonna tell you, okay? I do this, we do this in here. We do all students take calculus, because that's an easy way for us to remember it. Mr. Ryan doesn't do this, people, okay? Mr. Ryan doesn't do this. When he starts talking about the positive and negative values in calculus, he's gonna think on these terms. He's gonna say, think about the sine curve, guys. Think about the sine curve. When you're in the third quadrant, where is the sine curve? And some kids are like, what? What do you mean? Where is the sine curve? The sine curve, I didn't know. This is what he's talking about, okay? The third quadrant's between pi and 3 pi over 2. Where's the sine curve? It's below. So this is the way he's going to talk about it, all right? We did it like this. Are they the same things?
Yes.
Yes, they are the same thing, okay? They're exactly the same thing. This is a little bit easier. This is a little more in-depth, okay? Obviously, if you're going on and taking calculus, then your math skills need to be a little more in-depth. So he's gonna try to bring that back up to you. I'm gonna tell you this, the very first week in calculus, guess what? You're gonna have a test every day. Guess what it's gonna be over? Tell me the sine of pi over 2. Tell me the cosine of 4 pi over 5. Tell me all those trig values. It's your unit circle, people. Every day. Okay? Every day. So what's he trying to tell you? You need to know these people. You need to know them. All right? So make me proud. Make me proud. All right. Anybody got a question? No? There's not any way for me to pause that video, is there? No? Okay. All right, so I'm gonna give you the rest of not the rest, I'll give you about 30 minutes and let you work on your packet, okay? And then I'm gonna teach you something before you leave.
So we work on the packet now?
Yeah.